So here, I just want to spend half an hour, discussing the possibility of how that the high performance computing can be think on Azure platform, and Azure is one of the cloud platform by Microsoft. Okay, so just want to a quick check, like how many people have the background to high performance computing in the room? People are using already. If you can raise your hand, that will be helpful. Like or yes, no. Okay, yeah. So just kept a couple of initial slides, for those people who have kind of a little background or maybe no background. So the high performance computing is basically, that helps in doing the simulations, what otherwise will be kind of a cost, having more costly experimented, taking longer time, and for example, a simple car crash analysis. Okay, so either you build a complete car and then you crash, at a certain speed, and the impact which you want to see, the overall how that safety sort of, the standard that car meets. So what will be the impact at such and such level? So accordingly, the designers can, take a call how to kind of, make it more safer, to so that it can be more safer, and whether it is a change in material and all that stuff, those of decisions. So if you think from that perspective, building the whole model and making the complete car ready and then crash it, it's a very long, it will be taking a long. So what is the alternate? So you build a computerized model, which otherwise, like in the industry, people are kind of making those models, otherwise like all those CAD CAM designs are there, it's as they are doing. So that is already there. So with that, the applications of physics and the material strength and all those, the science background which is applied through the software, which helps these the engineers and the manufacturers to kind of do that simulation, and it is as close as to the the what you see physically. Similarly, like another example, like this is the aircraft engine, which is being the actual that the wind tunnel testing which is happening. So the same stuff which you can do it on a compute, or on a computing platform. Similarly, like even tornado, or these sort of the weather simulations, or all these simulations you can do. So the essentially, like it's the overall all these basic science which is applied in terms of calculations and mathematical models. These mathematical models are processed using the compute. So so if we say that why Azure, so when we say the labs which are required to kind of run, so there are thousands and thousands of compute servers which essentially kind of are required to do these simulations. So what option? So you build your, even that the time which takes to build these data centers and all, so that is also kind of a quite high. So in that terms, so if you want to have a quicker solutions to build your setup also, so Azure is the option, and we proudly say like it is 500 plus million compute core hours, which is already kind of Azure has been used. So people, it is something not new now, it is already being used, and Microsoft, being the experience in high performance computing, we have utilized those experience to make the platform available for the compute and high performance computing environment. So those skill set makes us different as compared to what other cloud providers are doing. So early 2012, we started our cloud journey in HPC with the the latest available processors there. So having the background of HPC, we assured like we are not virtualizing below the compute the processor level. Okay, so if there are two processors in the system, so we are not going in the virtualization of that below socket level, what we call it as, and even when you are kind of getting a complete system, that is kind of given the full system to you. So there is a bare minimal impact of the what do you call the virtualization. They and we assured like the processor which we are offering, that is in the the processor which is kind of at large used by the high performance computing community. So as a standard definition, it is kind of a below the top level, like a couple of the 2 3 down the line, the processor range which gives you the best price for performance. And the key factor we assured, like we have the InfiniBand there. We assured like the RDMA. Okay, so we assured that the RDMA, which is the key thing, which makes your the application to scale on a larger number of nodes. And so that is kind of being brought on a cloud platform, which is the exclusivity we hold in our cloud offerings. And there are it has been a kind of a time where the more and more applications are got ported on GPUs. So we assured like that the real hardware which is available for the computing environment by HPC community. So we are bringing those hardware, newer hardware. In fact, we have recent announcement wherein we have kind of brought the AMD processor recently launched, which is available on our cloud platform. And as soon as the Intel is releasing those processors, we are bringing in those processors on on Azure platform. And we hold the kind of exclusivity with that the offering. Cray like large, if you are looking for a 20,000 cores, 40,000 cores as a cloud platform, even we are offering that sort of the offering in the cloud platform. Yeah. So just quickly, like how it works. So the people who have just for the people already may not have the cloud platform, the background. So for them, so these are the data centers and all. These are spread across different the areas. So we call it as the region. And for example, like in India, we have 3 data centers. We call it as 3 data centers. So India as a region. And similarly, like there are 50 plus regions and more than 120 plus data centers, which are kind of where that these facilities are held. And as I mentioned, so it has the all sort of hardwares. It can be the processor, GPUs. It can be your even FPGAs. Those are specially demanded in case if you have written your applications on a the FPGAs, or if you want to utilize that the kind of a benefit of FPGAs, even those FPGAs are also available. So 50 plus regions we have, and 120 plus data centers. So what is kind of the advantage we can have is basically like you can first of all, like it brings you the flexibility to bring the systems immediately available to you. Okay, and in terms there is kind of the advantage where you can get the cost advantage in terms of how to plan when you are planning your data centers. So or when you are setting up your the compute facility for your HPC requirement. So it starts with even your basic building the data centers, arranging the requisite power, because when you are talking about thousands servers, so these requires more power, cooling and all that stuff. So here you need not to think about that from most of the times it the people get confused like how much we should invest on the data center side. I mean, should we really kind of put more 80% of our money into the data center side and keep on adding more and more compute later on? And so that, or we should invest more into the applications, licenses and all that stuff. So from that perspective, so cloud is the kind of the Azure gives you the flexibility to kind of move on. Start with your kind of initial requirement. It may be depending upon, like it may be starting with even few nodes if you want, right? So people who are kind of just starting their HPC journey, so they can start even with the say initial 2 nodes, right? And then they can grow to the larger number of nodes. It can be 1,000 or the 2,000 or any number. As I mentioned, like we have the arrangement with Cray, wherein even if you are looking for a 30,000 or 40,000 core of a kind of a the scenarios which you want to kind of put in, so even that is also possible. Yeah. So in terms of you don't have to kind of think and try to kind of compromise, like should we put more money into the data center and all that stuff. Yeah. So you're ready to go, and you can scale as and when required. And the whole beauty of thing is like the charge what you pay, the cost what you pay is for the instances which are kind of running during that time. So you are not paying for the time period when your machines are kind of in a offline state. So you are paying only when you are kind of that's a huge cost saving. So you're very sure, and most of the times, what happens is, especially in the scientific community, they do their simulation, and they do go back to the same simulation, and they go back into their wet lab testing and all, where they again that the time period which it takes, say roughly into 15 days or 20 days in their wet lab. So for that 15-20 days, those machines will be idle, right? So you have invested into your data center, you have invested into your infra, and there will be a period when these are kind of idle. So at that time, so the cost which you have involved in all that stuff, so that is getting wasted. So here that option is you run your simulation software for, say, even if it runs for, say, weeks or 10 weeks or days. So you run for those days and reduce it to the moment you stop it, and you kind of you save the money in that terms. Yeah. So the same kind of the stuff, like it is explained in a different way, like you kind of increase the number of resources when you need it, and reduce it when kind of you're done with that. And especially for example, like in this example, I'm saying like you start with, say, initial 4 nodes, right? And you find like you need more node to kind of reduce the execution time, and especially in the open source world. The open source community, wherein you are not paying anything for your license for the software which you are using. In that, this kind of increasing the increasing the resources or running or more number of cores, you are not adding the licensing cost, right? And in fact, the community who is adding to the source codes, people like you, when they are contributing and they want to kind of see the scalability. So what is the option you have? You have to kind of see that, whether that the changes what you have done, or whether the codes which you are kind of working on, it is kind of scalable enough. So either you kind of invest into the larger systems, or you kind of bring that larger systems temporarily, and kind of the moment your testing is done, and you release those machines. So, and say for example, like after increasing those say 7 nodes, you again bring down those 3 nodes. And similarly, from a storage perspective also, the scalability kind of lies, like you may start with some 20 TB of data, and you can increase up to a petabyte of storage also. So, and the beauty of it is like the kind of the amount which you are kind of storing, that is the kind of which is you are paying for that. And again, referring to the open source community, like where the most of the applications, like in case if it is taking, say, on 100 cores, it is taking 10 days, right? If then there is a high possibility, like you reduce by running your code onto 1,000 cores and reducing that execution time to a day, or maybe 1.5 day, because it is not a linearly scaling. Even if it is kind of there is kind of a instead of running it on 10 days, you can kind of finish your job into in a day or maybe 2 days. So wherein what you are getting is you are saving those simulation time. Instead of running it for 10 days, you are reducing that simulation time to 2 days or so. And whereas that the cost, which kind of in terms of the number of cores which you used, whether you run the the 100 cores for 10 days or 1000 cores for a 1 day, so the cost is roughly same. So that kind of flexibility you can get on a Azure platform. So that's what you kind of you can achieve. Your the research time or the simulations times, those can be reduced drastically, and you have the flexibility according to the size you want to kind of run on. Yeah. So many times I have seen, like, even if I interact right now also, like many people sees that being Microsoft, we might be a Windows platform, right? So we are not. Okay, we love Linux. Okay, so any flavor you call it as, whether it is kind of a CentOS, RHEL, you talk about SUSE. So all these sort of, even even if you want to kind of try some scientific Linux or so those possibilities are there. And we understand, like, the from the community perspective, like the CentOS and the open source, which is, so that is the basis, and we have assured the platform is available with all sort of Linux platform. Of course, the Windows platform is also available, and the HPC pack, what we otherwise kind of offer from Microsoft, and similarly, like the management software, the cluster management software, which are kind of running on a Linux platform, those are very much available. So as I said, like kind of you can you can scale up at any point of time, thousands and thousands of cores you can kind of a provision, and that provisioning is so quick, so fast, right? So if just try to imagine, like, in a situation, people who are using the HPC clusters, bringing a new 2 nodes, right, and adding to the existing cluster, it is a Herculean task. The complexity involved, like whether that the new hardware will sit along with the older hardware or not, whether it will coexist, whether the OS which is kind of currently on the cluster, that will kind of is it possible, can I put that same OS onto the new hardware? Then bringing those 2 nodes itself gonna take you at least 6 weeks to get your the hardware delivered from somewhere, the hardware vendor from outside India, right? Minimum time period like 4 to 6 weeks easily takes to ship. And if you add those the time period for a tendering process, people who are kind of in the tendering process and all, so that is a Herculean task. So it takes a hell of time to kind of get that. And here, like, you get those in minutes. And GPUs, building clusters also, like, we have kind of the softwares which kind of helps you in kind of delivering those the building the HPC cluster kind of environment. We have kind of Cycle Cloud, which offers you kind of provisioning these full-fledged cluster in few minutes and all. And of course, like, you can kind of have the big data platform, and those are available, ready to use. And not last but not the least, likely you pay what you kind of using it, right? So these are a few solvers which I kind of from open source community, which are like NAMD, CPMD, all these beside the commercial software, Linux platform, and the job schedulers, and these different compilers, and all these are available on Azure platform, and you can make use of those. Yeah, so the 3 choices which you can kind of have while kind of thinking of moving to Azure platform is, like, one option can be like you put everything, you start from a cloud platform itself, you build your complete data the cluster over there, and kind of use it, you put your all applications and data over there and use it. There is kind of a hybrid option wherein you can continue with your current, if you have some on-premise existing facility, and you can kind of integrate Azure along with that. We call it as a hybrid platform, right? You can continue with that. You can push your jobs, or the high-end jobs, or where you want to save the time or money, depending upon. So you can move those jobs on a Azure platform, And the third is that as a service. So we have kind of a batch services which offers kind of you bring your application and data and you're ready to go, and the job starts immediately. Yeah. Uh, so this is the kind of a deeper down details, like how it works. Like you bring your bring from your laptop, you just bring your application and data to the Azure platform, and the batch service kind of is ready to kind of deliver that. People who have the doubt wherein how that the performance will be there. So this is the example like where we have kind of tested the applications, and uh, we have kind of almost delivered the same performance what otherwise you would have kind of got from a physical hardware lying in your data center. So this is the curve which kind of completely shows that. And this is the last slide which I want to share with you, is that this is kind of a car racing is kind of in the background when the car racing happens. So they do all those simulations in a real time, like what really that the they get the real capture the real data and all, and they do all those simulation what is going good not right. So that is on a need basis. So they kind of they are running on Azure platform and they are happy, and they can reduce like their kind of a time to go, they are reduced by that one. So that is a quick the introduction on a Azure platform I wanted to share with you guys. I'm reachable at parveen.kumar@microsoft.com. You can happy to interact, and I can take a few questions if I have time. Yeah. So, okay. So I'm happy to take any questions, if you are, yeah, sure. Okay. From that perspective, to be very frank, the way I said in a hybrid mode, okay, that flexibility, especially for the high performance computing, I would call it as. So we have the flexibility. You can kind of push few nodes taken from Azure platform that we are offering. Okay, if the AWS is ready to do that sort of thing, I mean that's a difficult to comment from on the behalf of them. Yeah, so I mean there are people who are kind of the SIs or that sort of people who can kind of do that job for you. Yeah, so that is either can come from the SIs or from this one.
Yeah, hi.
Hi.
Yeah, hi. I'm Amar here.
Hi,
So, what you say is like the billions of dollars that R&D, like in companies invest on R&D labs.
right.
People pride that I have like a huge data center with latest compute storage network. So, your last slide where you shown that bare metal and Azure HPC. So, go head on head in terms of performance.
Right.
Okay.
Yeah, so that's what I said. We have kind of assured, for example, that having background in the HPC, we assured like at BIOS level, we are fine tuning those particular machines, because in a cloud platform also we have dedicated machines for HPC. We suggest for HPC workload, and beside the other hardware, those other hardware are kind of recommended for other workloads, but these machines are assured BIOS fine tuning, the OS level fine tuning, and not kind of having impact of a virtualization on the applications running.
Right, and one more thing is, has FPGA also entered HPC, or is it still on GPU?
Yeah, so I mean the FPGAs, the way like it is there is, in fact, like there are people I have been kind of seeing few people have been using the FPGAs since my 2007 or 2005 kind of environment. So for few scenarios, those FPGAs are kind of advantageous, where people are kind of taking the advantage a decade back and currently also. That's where like the flexibility, where we have taken a call to make those FPGAs also available. Yeah. If I put that question in a right perspective, so how much how secure the systems are, right? Is that, or like people are kind of using the using the base as for the okay. So I mean there are certain kind of the system kind of the analysis or the reports which we are generating. Okay, so I need to confirm is whether those sort of activities are kind of also being monitored from that perspective. But from a security perspective, we have taken the sufficient, this is not the, so from that perspective.
How Azure will assure that it is used ethically, the system?
Yeah, so I mean, from any kind of those reports are there, like which can help us in guessing those unethical activities being tried out there, because as an HPC user, so you will be having some session connected and then you are running within the system. So if trying to do anything outside or in a different way, maybe those reports can help us to, yeah.
Praveen, you mentioned that you support hybrid with Azure. So,
Yeah.
say I'm running a Proxmox virtualization platform on my local infra, and it can be extended to Azure. Do you mean by that?
So the way, yeah.
Yeah, I want to extend the open source virtualization platform to integrate with Azure as a platform on the cloud. So
Right.
Is that possible?
Okay, so from that perspective, when I say the hybrid scenario is possible, so the same the job schedulers and the master node with which you have kind of provisioned your cluster, it may be virtual on a virtualized platform, or it may be on a actual physical hardware. So there are mechanisms possible where kind of a VPN, your VPN, or the gateway, or the complete networking is kind of opened in a such a way, the virtualized machines which are kind of instantiated on Azure platform, those are kind of integrated with your cluster environment. That's what I wanted to say.
Some API connector.
These are not really the API connect. So for example, like a PBS job scheduler. So I mean, from a HPC environments where like these are not really the API sort of stuff. It is more of a say job schedulers. They are offering that integration with that the overall thing. So the node can come from the network which is opened. Your network is opened for a Azure integration. So since they are looking at that the at a similar network, this one network segment, so those are kind of extending, because in the HPC scenario, as long as you are in the same network thing, you will be able to kind of add as many as nodes you want. So the system which are there on premise, those doesn't know like these systems are kind of remotely there, because they are kind of looking like to the master node, it looks like as good as these are my babies and I can run my jobs. Correct. So the networking, this is more of a networking thing which is taken care and rest is done. Rest you are kind of, yeah.
Praveen, this is Avnish. I have
Hi,
a small
Avnish.
question. So when it comes to HPC, is Microsoft providing as a P0 kind of a thing, like it is a provisional as a basic thing for any new data centers coming up, or it is region specific?
Well, I
Because
mean,
my question here is, when you are using a high compute environment, right? When I say terms in the performance, I want my hybrid environment to be more close to the cloud itself. I just don't want to travel across a huge amount of data over the network. So is it available in South India region, or it is still specific or limited to America region or something?
okay. So in India, we have three data center, three locations. One is in Chennai. We call it as South India region. And one is in Pune. We call it as Central India. The third is in Bombay, which is West India. So the location perspective to answer, yes, that is there. And so I think we are running out of time. Maybe I'll take this last question and we can take I'll be available during lunch, or I'll be here around. Okay, we can take it offline also. So to answer you back for that, from a latency or from when you are talking about the data transfers and all, so there we have the mechanisms called Azure, wherein if you are kind of in a scenario where the large data transfer which is required, so that Azure platform, like the data which is there on your premise, that can be accessed and cached onto cloud. So the cloud, the nodes which are accessing the data, it doesn't matter like whether that the data is kind of kept here on your premise, because it is caching those data. So those it is caching mechanism which helps you to kind of bring the data faster onto the cloud and vice versa. Thank you very much for your time, and I'm available, like I'll be around here, and I'm happy to take any offline questions if you have. Thank you very much.